Welcome to the content material for Class 4 of Engineering Statics. You should be watching this video before your 4th class. In this lesson, we will cover the following topics. We'll talk about how to break up or resolve vectors into its x and y components, and we'll talk about Cartesian unit vectors. In the previous class, we saw that we can break up a force or resolve a force vector into two components, such as the example we looked at where we broke up this force into the components along the u and v axes. It can be convenient for us to break up a force into its x and y axes, and that's what we're going to talk about today. So if we have this force F and we want to break it up into its components along the x-axis and y-axis, this can be very useful for us. So let's learn how to do that. So if we take a force and break it up or resolve it into two components along the x and y axes, those components are called the rectangular components or the Cartesian components of that vector. In other words, the vector F is equal to the two components Fx and Fy. And we can define these components Fx and Fy based on the angle theta from the x-axis. So we see that the magnitude of Fx is equal to F, the magnitude of F, times cosine of the angle theta. And the magnitude Fy is equal to the magnitude F times sine of theta. And if we know the ratio of the height to width, we can use that information instead of the angle theta. So for example, if we know that the ratio of A to B, we can use that information to solve for the magnitude of Fx this way, rather than using the angle theta. So Fx is the magnitude of Fx is equal to the magnitude of F times A over C, being the ratio of the width or the length to the height of that vector. And similarly, f of y is equal to the magnitude F times B over C. So these equations will be really useful to us as we try to break up the components into the x and y components in 2 dimensions. And we can use the properties of a triangle. If instead we already know Fx and Fy, we can determine the magnitude of that vector F. Similarly, we can use that information to solve for the angle theta if we're trying to do that. So all of these equations here will be very useful for us, and you'll be sure to write those down and keep those in your notebook. Now when we talk about Cartesian units and we talk about breaking up a force into its x and y components, we have special notation for that called Cartesian vector notation. And so we're going to use these Cartesian unit vectors, and the unit vector has a length of 1. And in the x-axis we use the notation of I. So the vector I, we can write it this way. I usually write it with a hat, so I hat, sometimes I call it that, which is the unit vector in the x direction. And in the y direction we use the letter J, so you can choose to write it like this. I usually use the hat. So J hat is the unit vector, so length of 1, of a vector in the y direction. And so we're going to use these to say that the vector, any vector f, is equal to the magnitude of the vector in the x direction times the unit vector in the x direction, I hat, plus the magnitude in the y times the unit vector in the y direction. And so writing it like this is called the Cartesian unit form of the vector. And this can be useful for us if we need to add up several forces together. So let's look at this case where we have 3 forces and we're interested in what the resultant vector is, or the resultant force. So if we add up F1, F2, and F3, what is the resultant force, Fr? Well, we know it's the sum of those. So if we break up each of these forces, F1, F2, and F3, into its x and y components, we can easily add them together. So we start with F1, we find out its x and y components, F2, F3, and then we can add each of these together. We can add up all of the x components and all of the y components to get Fr. And that's exactly what we do here. So break up F1, break up F2, break up F3, and add it together, and now we have the resultant force. So the best way we can do this is to look at some examples. So I'll show you some examples of how to break up forces into their Cartesian components and how to add them together. Okay, in the first example, we have two forces acting here, which are F1 and F2. So we have F1 and we have F2. And we're asked to find the x and y components of each one. So what we need to do is break up these two forces, F1 and F2, into their Cartesian vectors. So the first thing I'm going to do is I'm going to draw F1 as its x and y components. So here's F1, and I know that there's a component F1x and F1y. And I could draw that now as a triangle. And if I call this angle here theta, which we're given, I know that adjacent to that is the cosine, and opposite of that is the sine. And so we see in this case that F1x is equal to F1 sine theta, and that F2 or F1y is equal to F1 cosine of theta. Here's our F1y. And so we have these values already. We know that theta is equal to 30 degrees. So I can put these values in. We know that F1 is 200 newtons. Put these values in here. And we see that F1x is equal to 100 newtons. And it's going to the left, so that's negative. And we see that F1y is 173 newtons, and that's pointing up, so that's positive. Now we can do the same thing for F2. F2, in this case, points this direction, so we have the F2x, and we have F2y. And we see that here's F2. In this case, instead of an angle, we're given the dimension. So we see that for every 5 it goes down, it goes over 12, and the hypotenuse of that triangle is 13. So again, I'm going to draw a triangle here. So we have F2x, F2y, and we can call this A, B, and C. And we know this has a length of 12, or a ratio of 12, ratio of 5, and a ratio of 13. So I'm going to use my equations this time that F2x is equal to F2 of the ratio of A over C. So I have A over C. And that F2y is equal to F2 of the ratio of B over C. And I have all these values, so I want to plug them in. So 260 newtons is what F2 is. And we have this ratio 12 over 13. Same thing, I'll put our values in here, 5 over 12. When we solve, we see that this is 240 newtons, this is 100 newtons, This is acting downward, so that's going to be a negative. This is acting to the right, and so that's a positive. Now the last thing we need to do is we need to add this up. So we see that the f1 vector is equal to f1x plus f1y. And we're going to use our Cartesian unit vector. So we know this is negative 100 newtons with the x Cartesian unit vector, I. And this is 173. And here's our y-axis Cartesian unit vector, J. And we have the units there of newtons. Same thing for F2. F2 is equal to F2x plus F2y. And so we use our values, 240 minus 100 units. And so this is our answer that we're looking for. Okay, in our second example, we again see that there are two forces here, F1 and F2, but this time we're asked to find the resultant force. And we're going to express it in two different ways. So first we want to find that resultant force Fr, we want to find the magnitude of it and its direction, and we can call that angle theta. And we also want to be able to express that as a vector using our Cartesian unit vectors. So again, the first thing I'm going to do is draw a diagram. Start with the x and y axis, and I see that force 1 goes this way, and that force 2 goes this way, and there's going to be some resultant force, maybe about like that. And that's what we're trying to find, and so that angle theta is going to be like that. And so the first thing that we can do is start by figuring out what the x component of the resultant will be. We know that the x component of the resultant will be the sum of all of the x components, which is f1x plus f2x. And same thing for the y, f1y plus f2y. And so we can use this information because we know that fr is equal to the square root of these squared. So frx squared plus fry squared. So as long as we can solve these, we can plug them into this equation to figure out what fr is. So let's do that. So let's work on f1 first. Again, f1 is pointing this way to the right, so we see that f1x and f1y are the components of f1. And we know that this angle is 30 degrees. So I'll draw a triangle, 30 degrees, f1x, f1y, f1. And now I can use trigonometry. f1x is equal to f1 cosine of 30 degrees. f1y is equal to f1, it's the opposite, so sine of 30 degrees. Plug our numbers in. And solve. So here we see 519.6 newtons, and this one would be 300 newtons. And then again, we want to check the direction. So this one's to the right, that's positive. This one is pointing up, also positive. Now we're going to do the same thing for F2. F2 is pointing this direction. So we have F2y, F2x, and And we know that this angle here is 45 degrees. So again, draw a triangle here. We have F2y, F2x, and our angle in here of 45 degrees. So in this case, F2x is equal to the sine of this angle because it's opposite. So we see that F2x is going to be equal to F2 of the sine of 45 degrees. F2y is equal to the cosine because it's adjacent. Plug our values in, we see that F2 is 400. So we have 400 sine 45, 400 cosine, and we can solve. This one will be 282 newtons. Going to the left, so that's negative. This is the same number, but again, this is pointing up, and that's positive in the y direction. So finally, we put them together. So FRX is equal to F1x plus F2x, which is equal to 519.6 newtons, minus 282.8 newtons. Solve. 236.8 newtons. That's to the right, and therefore positive in the x direction. Fry is equal to F1y plus F2y. I'm going to add our two numbers together. 300 newtons plus 282.8 newtons, or 582.8 newtons, pointing up in the positive y direction. So finally, we can put this information together. Fr is equal to Frx squared plus Fry squared. And when we plug these two values in, when we plug in our 236, our 582, we get an answer of 629 newtons. So the resultant force has a magnitude of 629 newtons. But we don't know the direction yet, and that's where we need to find theta. But we know that theta of the resultant is equal to the inverse of the tangent using the ratio of Fry and Frx. So we have those values already. Plug them in. And when we do that, we're going to get a value of 67.9 degrees. So we have our answer thus far for the first part. Fr is equal to 629 newtons, and the direction that it's pointing is 67.9 degrees from the x-axis. And so we'll circle that as our first answer. The other thing we wanted to do is to express this in Cartesian components. So that's going to be equal to Frx with the Cartesian unit vector I plus Fry j hat. And so we could add up each of these numbers separately, but we've already done that, right? So we've already gone up here and figured out Frx and Fry. But quite simply, F1, just as a reminder, is 519.6 I hat plus 300 j hat, while F2 is equal to negative 282.8 I hat plus 282.8 j hat. And so we can add those together. and we end up with an answer of 236.8 in the positive x direction plus 582.8 in the positive y direction. And so both of these answers are the same. This answer here and this answer here are equivalent but expressed using different ways. This one we use the magnitude and the angle, whereas this time we use our Cartesian unit vectors. In our third example, we again see two forces acting, but this time they ask us to determine the angle necessary to get the certain result. So what we're going to solve for is the angle theta and the angle phi, as drawn in the diagram. So the first thing that I'm going to do is also write out what we know. We know that the resultant force has a magnitude of 20 newtons, and we also know that it says that it only acts in the positive x direction. So in other words, we can write it as in vector form with only the I direction. In other words, the unit vector I in the x direction with no j. There's no force acting in the y direction. And this will help us because we know then that frx is equal to 20 and fry is equal to 0. And we're going to use these two pieces of information to solve. So the first thing we want to do is we want to break up our two forces. So I'm going to call them force 1 and force 2, and I'm going to draw it as we're used to seeing it. So I'm going to kind of tilt it with the x and y direction this way, and we see that there's one force going this way, and one force going this way, and this one is theta, this one is phi. So I'll call this one F1, and this one is F2, and they're both equal to 30 newtons. And we know that the force of the resultant is going to go in this direction, and it's equal to 20 newtons. And so we have to solve for theta and phi using that information. Well, first thing we got to do is break it up. So draw my triangle, F1x, F1y, theta. And we know that F1x is equal to F1 cosine of theta. F1y is equal to F1 sine of theta. And they're both positive. So positive in the x direction and positive in the y direction. You can do the same thing with F2. So here's F2, and this is the angle phi. And this is F2y and F2x. And so F2x is equal to F2 cosine of phi. F2y is equal to F2 sine of phi. And we know that, again, this acts in the positive x direction, but the y is downward, so it's negative. And so now we can create equations for frx is equal to F1 cosine of theta, so F1x, and F2x plus F2 cosine phi. And we also know that Fy, and we know that that is equal to 20 newtons from our information up here. We know that Fry is equal to F1y, so F1 sine of theta, plus F2y, F2 sine of theta, and this one is going to be negative. So I need to make sure that here we have a negative sign because this value is negative. And this is equal to 0. So the first thing we can do is solve this equation because we see that F1 sine of theta is equal to F2 sine of phi. We see that this is 30 newtons, and this is also 30 newtons. And so we see that in fact, these cancel each other out, that phi is equal, or theta is equal to phi. So this will be helpful because now we can use that information to solve our second equation. We have two unknowns, two equations, so let's solve this one. So we can say that F1 cosine theta plus F2 cosine of theta again, because we know that theta and phi equal each other. So we can put that information here, is equal to 20 newtons. So F1 plus F2 times cosine of theta is equal to 20 newtons. And F1 plus F2, well, each one is 30 newtons plus 30 newtons. So we see that cosine of theta is equal to 20 newtons over 60 newtons. And at this point, we just solve for theta. Theta is equal to the cosine, the inverse of the cosine of 20 over 60. And when we do that, we find that the answer is 70.5 degrees. So our final answer, theta, is equal to phi, which is equal to 70.5 degrees. And this is the answer that we were looking for. Okay, so that's the last example that we're going to look at. Be ready to do a problem similar to this in class as the starting quiz, and we'll be sure to review all of this information in class. We'll see you then.